Man is often called the cooking ape. Food defined us in the sense that when we started grilling and cooking our food, we changed into something different. We became man with a large brain, and we conquered the world for good and for bad. So food is very important, and food in a rapidly changing world is even more important. Are we able to feed the coming billions, and are we able to feed ourselves in a sustainable manner? Urban agriculture is thus part of the solution. And the first speaker on nutrient recycling and urban agriculture part is Petter Jenssen. He's a professor at NMBU, Emeritus, on circular solutions for sustainable cities.
Thank you. Thanks for inviting me. First, I would like to draw some attention to Melissa, who is sitting there. He's responsible for several of the results I will talk about. So I found it natural that his name would be on the presentation as well. And many of the results that we are going to talk about come from an EU project that we conducted some years ago. It was a large project, 70 million euros plus Chinese funding. And Melissa was part of it, Trina was part of it, Siv was part of it. Yeah, many people at NMBU and other places. Erik talked about cities as large importers of resources, being water, energy, food, and so on. They're also large exporters of air pollution, water pollution, climate gases, and it's linear, mainly. If we want to make a sustainable city, we need to close these loops. And the goal and the visions of the SIU Green project was to try to close some of these loops. I will talk about some of them, mainly about the wastewater. And by closing the loops and also growing stuff, make the city greener, we could promote well-being, as we heard about also in the panel just before here. Reduce water and energy consumption by actually up to 90%. And thereby, at least almost, eliminate some emissions and produce food for the city based on local resources. So that's circular economy. To do so within the wastewater sector, it's natural to go to something called source separation. I don't know if you know what that is. But that means we take what comes in the toilet, in the loop you see there to your right, and we can make energy, fertilizers, and subsequently food that we return back to society. We can also take the rest of the water and return it to various purposes, even drinking water. And why is it like that? What we excrete in a day is a mere 1.5 liters. And that contains the majority of the resources, 90% of nitrogen and phosphorus, plus other nutrients, more than half the organic matter, and of course most of the pathogens. And this we mix with 150 liters of water, just make it run through the pipes to the treatment plant. If we start from scratch today, I don't think we would have developed a system like that. We would do like we do with solid waste, go to source separation at the source, and then we can have an interesting development. It's also pointed out by the Finnish Environment Institute that if we really want to recycle or recapture, for instance, nitrogen and phosphorus, we need to go to source separation ultimately. Not only in new housing areas, but also in existing. And this is what we have demonstrated here at Ås. There is a lab here up on campus headed by Professor Arve Heistad, who's not here today. And there we took the wastewater from the student housing using vacuum toilets, because we need to use a toilet that uses little water. Vacuum could be one such option. And we take this wastewater into a biogas reactor. We could also add the organic household waste to make more biogas. And when we burn off the biogas, we can co-generate electricity. We have heat that can be funneled to a nearby greenhouse. We also have CO2 that can be funneled to the greenhouse. And we have a lot of plant nutrients in various ways that we can use to grow vegetables. And what we filter off, we have composted and made into a soil amendment product. And Melesse, he has been a very active postdoc in this project, dealing with many interesting developments. Here you see it take the biogas digestate, and he has grown algae. We heard about algae by Dr. Gupta. Algae in our project removed more than 90% of the nitrogen and phosphorus was in the algal biomass. Algae can be used as fodder, organic fertilizer, soil improvement, and we heard also other things in the previous talk. Can produce oil, can produce hydrogen, biodiesel you heard. Many things for industrial purposes. So here are many commercial options in the green shift, creating new jobs. We also produce something called struvite from both urine and digestate. Struvite is the same mineral as in kidney stone, magnesium ammonium phosphate. And struvite is a slow-release fertilizer containing nitrogen and phosphorus. It's also certified in organic as well as conventional agriculture in Europe. And again, Melesse has at least four pilot projects, ways of how to generate struvite that can be commercialized. There are commercial systems today, but here are more possibilities, also to do this in smaller scale. We have a greenhouse here at campus, right next to the biogas reactor lab. This greenhouse is insulated by soap bubbles, so we have good insulation in winter, also insulation against heat in the summer. We can grow year-round. That was our goal. Another advantage of this greenhouse is that it has a different ventilation from other greenhouses. You can funnel CO2 there. You can raise the CO2 level. And higher CO2 level is more optimum for growing plants. Greenhouses is something I see that will come. This one is from Berlin. I saw in a Swedish commercial paper that many investors in Sweden were talking about producing larger amounts of tomatoes and other crops in greenhouses in Sweden, that this was becoming profitable. This one in Berlin was on imported resources. We used the waste from the city. And we can grow a lot in a city. This is an example from greenhouses in Norway, 150 kilos per square meter. But imagine if we stack them, we could boost that per square meter. And in the city of Havana, they produce, not in greenhouses, because they're warm climate, 60% of the vegetables that they consume are produced within the city limits. When we started a project, we didn't think we could produce any energy crops. We did a little experiment with pallet boxes and grew 35 kilos of potatoes per square meter. That equals 35 tons per hectare, which is about 15 times as much as a farmer is happy about if he gets it in his field. And people are engaged in urban agriculture. Increases well-being, we saw that in the project. So that's another aspect of it that's important. We have made biogas and fertilizer from the black water, that is what comes from the toilet. What about the grey water? The grey water, when you use a vacuum toilet, constitutes more than 90% of the water flowing out of the house. And here is a plant in Oslo, in the backyard of a building in Klosterenga, built in year 2000. We had another project at that time. It's still operating. It's still operating very well. It's drinking water quality regarding nitrogen. It's swimming water quality regarding indicator bacteria, and way below the discharge limits for BOD and phosphorus. Think about this water. Much better than many raw water sources for drinking water worldwide. So could we make drinking water here? We did. And if the grey water constitutes 90% or more, if we could recycle the grey water and only take 10% new for drinking and food production, we could save 90% of water, which was very interesting for the Chinese. Beijing is running out of water, and that's the case many places around the world. So, summing up at the Living Lab, we can recycle more than 90% of nitrogen and phosphorus. If we return it as a liquid, we also get all the micronutrients, we get the potassium, and so on. I haven't talked much about it, but this system runs with a net energy surplus. And it's decentralized. It can be used for new developments within the city. I know that the city of Hamburg, in many cases, need to, if they want to put more people into an area, they need to go to vacuum toilets because the sewers don't have capacity, and it's extremely expensive, as you know, to rebuild sewers. We see that in Norway now. Prices are rising. It's also another point here. It's resilience. This is a decentralized system. Think about Ukraine. I've been involved in making dry toilet drawings together with a Ukrainian friend for people in Kiev and other cities where they are bombed. What should they do when water is out and the sewers aren't working? With decentralized systems, it's much more resilient in a crisis situation. It's much harder to do any sabotage. And we need, unfortunately, to think about that now. So, to sum up, I think future cities can become hubs in a circular economy, where we turn waste into bioenergy, fertilizer, biostimulants, and thus near eliminating water pollution. And the decentralized water infrastructure that we have demonstrated in the Sea Green project can produce potable water, so we can reduce the consumption by 90% if we want to. And also greenhouse gas emissions, we can increase the resilience of the system, and we can have greater flexibility in urban planning. Thank you.
Now, Petter is from Trondheim. I just mentioned it. Yes. Now, this to me seems almost as if you are on the verge of obtaining a Nobel Science Prize or something. I mean, if this is true, you are really on the verge of a revolution. Or?
Yeah, I totally agree. But how for it to come about, that's a question. We have just discussed it down at the table here before I went up. Why isn't it happening?
Okay. Any comments or questions to Petter? Yes, there, down here.
My name is Tore Hansen. I live in a nearby group of buildings called Kaja. Peter used to live there before. When we moved in 1993, we had to renovate our water and sewage system in the house in 1995. Then I asked Ås kommune if they were looking at Peter Jenssen's studies here at NMBU at that time. He had newly built the system he was showing by the student dwellings, but Ås kommune didn't actually know about this, and they didn't recognize to divide black water from the grey water. What is happening in Ås now? Do you know, Peter?
Nothing much. It's it's in a way a sad story, but Erik talked about economy, and we are looking into, I predicted 40,000 crowns per household in water and sewer fees, and maybe it's even going to be more costly if we continue to use the systems that have given us these costs. So Stockholm municipality asked us to join in a proposal to the EU for driving urban transitions program, together with Paris and Klosterenga in Oslo, and the guy sitting there. So they are thinking ahead. In Stockholm, they want to use the grey water systems as we had in Klosterenga. But in Oslo, well, they hesitated hesitantly. They have been involved through Osmund, who has, maybe has left. Anyhow, there is interest other places than in Norway. You can't become prophet in your own country, maybe. But I think the costs that are showing up now, and municipalities calling to my colleague Arve, for instance, saying, we can't build anymore. The sewer system is overloaded. We can't build until 2030 in Trysil, for instance. Something has to happen. And now is the time.
Yeah, thank you so much. It's really interesting. I was member of a municipal council in a neighboring municipality here 25 years ago. And I don't know if you remember, but in Hobøl. And you came 25 years ago, you came and you tried to convince us to build a natural-based sewage treatment facility. And I was very much for that, and we managed to get a majority. But it was stopped from the fylkesmann at that time. And now, 25 years ago, I'm coming here, and it's still only here at NMBU you hear about it. We have a crisis with nitrogen into the Oslofjord. Phosphorus is a limited resource. And we still just talk about it in academic circles. It's quite tragic, actually. But I think the main reason is, or at least one important reason is what we heard in one of the first presentations today, that cheap is better. It's the economic models not taking externalities into consideration. We don't take planetary boundaries. We don't take social justice into the economic models. The science of economy is not following the time, and we need to challenge that a lot, because we need to take externalities and planetary boundaries into the economic models. Thank you.
Now, this is very, very interesting. NMBU obviously has a role to play in this. Planetary boundaries, correct. Last comment from you.
Yeah, and regarding cheapest, we calculated for Fjordbyen, that's Stefan who's sitting here, a couple of years ago. That's 10,000 people in a new development in Lier and Drammen area. It was considerably cheaper to go decentralized with systems like this. Maybe around 50% in investment and 75, I think, if I'm right, on operating costs. Looking at only those two. But then if you pull in all the other stuff that you were talking about, and that Arild Vatne and I wrote about in 1991 in a paper, then this would definitely be economically better.
Jolly good, Petter, keep it up another 25 years.
Thank you.